we are going to do Newton's laws. So now you must, if you didn't watch my previous videos of vectors, go back there because we are going to use that now. And this will be the shortest video because we'll be focused on Newton's first law only. I didn't want to mix them. I don't want to mix them because you will be confused. So we're going to separate them. Each lesson, each live lesson, we're going to separate, and we are going to separate them. Next time we meet, we are going to do Newton, dealing with Newton first law. But first, you need to understand the following, because you'll be dealing a lot with forces. You need to know what is a force. I'm going above and beyond to get everything for you. Hence, I'm writing everything down. You won't see me carrying a textbook, coming here carrying a textbook. I won't do that. Everything I'll be presenting here will be in a paper, because the information here, I go underground and dig the information. Now let us understand what is force of what is pulling. A force of this is pulling. So you must understand what is a force. The definition of a force is anything that can cause change to an object. A force is anything. They are saying is anything. So anything that can cause a change into an object, that thing is regarded as a force. So, and then our next point is saying forces can do the following. Forces can change the shape of an object. So box in an empty square box. When you put a force on that box will bend. That means you apply the force, and then because the box bent, now you change the shape of the box from being square into another shape. So now you apply the force, and then you change the shape of the box. And then they are saying forces can accelerate or stop an object. For example, let's say you are throwing a ball. You throw a ball. Now that ball will go into whatever direction that you threw or kicked it. So now, and then you can also stop the ball, because if someone throw a ball at you or someone kick the ball at you and then they scream, hey, stop the ball for us, and then you can stop the ball. You are applying a force by stopping the ball. If you didn't stop the ball, that ball was going to continue moving into whatever direction like that. But now, because you stop the ball, you apply the force and then you stop the ball. Our next point is saying forces can change the direction of an object. Again, I'll take the example of a ball. When someone kicks the ball at you and then you stop the ball and then you kick the ball back at them, now you are changing the direction of the ball because the ball was coming towards you. Now you stop the ball and then you kick the ball into that into another direction. Now you change the direction of the ball. And then our next point is saying a force can be classified as either contact force or non-contact force. So we have two types of forces. We have contact force and non-contact force. The words are saying the words are just there as they are, contact and non-contact. So let's try to understand what is a contact force. A contact force must be touched or be in contact with an object to cause change. So for a contact force, there must be a contact with an object. You must have a contact with an object to be regarded as a contact force. You must touch the object so that it can change direction or it can move. You must touch the object. For example, the ball example again. When you kick the ball, you are making contact with the ball, so the ball will change direction because you made contact with the ball. When you open the door, when you enter your home and open the door, you are applying a force, you are applying a contact force in the door. So now the door will open because you made contact with the door so that it can open. Now we are going to a non-contact force. A non-contact force does not have to touch an object to cause change. It touch the object to cause change. How? Let's take for example wind, the air, the wind. When the wind is blowing and then there are papers outside, the papers will start moving around. They'll start flying. You'll be surprised why the papers are flying. Because no one is throwing the papers up, no one is kicking the papers, but the papers are flying. What caused the papers to fly is the wind. That's a non-contact. When the windmill is rotating, when there's no wind, the windmill will stand still. It won't move. But when there's wind, the windmill will start rotating because there's wind. That's a non-contact force. Another example, I can take a magnet, for example. A magnet. When you put a metal closer to the magnet, the magnet attract the metal. There's no hand that is moving from the magnet and take the metal. The metal just is pulled into the magnet. That's a non-contact force. That's a non-contact force. So I hope you will understand this part. Now we are moving into another part. Now definition. We are defining. Grade 11. These are free marks. Free marks. These are free marks. Definitions, you must know how to define. You fail to define, hey, you have a problem. You must know how to define. These are free marks. These are the marks that you must take. Let's do like this. Okay, let's define a normal force. A normal force is the force exerted by a surface on an object in contact with it, and which is perpendicular to the surface. They are saying a normal force, it's a force that is exerted by an object on a surface. It's a force exerted by a surface on an object in contact with it, and which is perpendicular to the surface. So the normal force is acting up always. The normal force will act up because it's perpendicular to the surface, so it will act up always. It cannot act right, it cannot act left, because that way it's horizontal. But now we are dealing about perpendicular. They are saying a normal force is a force exerted by a surface on an object in contact with it. So the objects must be in contact with the surface, and the normal force is perpendicular to the surface, so it's acting up. It cannot be perpendicular if it's acting left or right or parallel. Now a frictional force. Let's go into a frictional force, because these ways are going. We are going to be focused on a normal force. We are going to be focused on a frictional force and the free body diagram. Now a frictional force is the force that opposes the motion of an object in contact with the surface and which acts parallel to the surface. You see, the frictional force is acting parallel and the normal force is acting perpendicular. So now the frictional force is acting parallel to the surface. When an object is going right, the frictional force will go left. When an object is going left, the frictional force will go right. If an object is going up, the frictional force will go down. If an object is going down, frictional force will go up. It will always oppose the motion of an object. So you will know when you want to draw a frictional force, you will know that when an object is going right, they will tell you that an object is going into a certain direction. Maybe they can say the object is going east, the object is going west. You will know that when an object is going east, the frictional force will definitely go west. Let's go into a free body diagram. Free body diagram, people are getting free body diagram wrong. And if your free body diagram is wrong, everything is wrong. If you fail to draw a free body diagram, I remember when I started tutoring in my previous high school, I came with that mentality of saying maybe people, they know what a free body diagram is. So I gave them question, draw a free body diagram and then you calculate 1, 2, 3. I don't want to. Things I saw, the things they draw me, because you cannot draw an aeroplane. If they said an aeroplane is going east, you cannot draw an aeroplane in arrows. Understand the definition of a free body diagram. Free body diagram shows an object as a dot and the forces that act on an object as arrows that points away from the dot. An object is represented as a dot, whether it's a train, it's an aeroplane, it's a box, it's a car, it's whatever. You change that object and then you represent it as a dot. You cannot redraw the object. See, if they say a box is going east, you cannot draw a box. If they say a car is going west, you cannot draw a car. You cannot. The definition is saying the object is represented as a dot. You need to draw a dot and arrows that points away from the dot. I hope you understand it. If you don't remember with the free body diagram, it's easy, because if you don't remember actually the definition, you can draw and then you can remember the definition. If you don't remember the drawing, you need to remember the definition. Definitely you can draw. So you need to remember one of them. If it's not the definition, that's the drawing. So now we're going to our next We are going to our next theory. We are going to calculations, don't worry. Newton's first law. We are going to Newton's first law. Now, how can you know? How can you tell that they are talking about first law? When you see words like moving at constant or uniform velocity, you know it's first law. You don't have to think twice. You know it's first law. You need to change your mind into first law. Another ways that you can find objects, it's stationary or still or not moving. You know they're talking about first law. The acceleration is zero. When they are talking about first law, the acceleration is zero because the object is not moving, it's stationary. When the object is at equilibrium, the word equilibrium means stationary. So you must not be confused by their fancy words. Just relax. Just relax and try to understand what they are talking about. When they say the object is at equilibrium, the object is not moving, it's at rest. So when you apply the formula F net equals to ma, acceleration is zero. Acceleration is zero. So m times zero is zero. So it's zero. So now let's state Newton's first law. Newton's first law is stated as following. Grade 11. Grade 11. This is a law. This is a law. Newton's first law. It's a law. Where's my mark? Highlight, I mean. This is a law. We are dealing with the law. You cannot change the law. We are no longer defining. We did definitions, free body diagram. We did definition, normal force. We did define a frictional force. We were defining. You define using your own understanding. You define the way you understand something. But this is a law. You cannot change it. You are not allowed to change it. You see, me and my colleague, if you can go to her video, into her lesson, she was teaching grade 12s about the laws, these Newton's laws. So me and her, we are stating the same law because this is a law. We cannot change this. You are not allowed to change it. You see. So now you must state the same law. You are not allowed to change the law. You can change the definition, it's fine, because you define the way you understand. We understand it, it's fine. But with the law, you cannot change the law. If you break the law and then, let's say you break a South African law, number one, you must not steal. You decide to steal. If you steal, you go to jail. You are punished. So now you go to jail. Even here, you change the law, you'll get zero. It's like that. You cannot change the law. Let's define Newton's first law of motion, because tonight actually, we are looking at Newton's first law of motion. I only have two examples for you. Just two examples. We're just gonna do two calculations and then we are done with this lesson. We are closing Newton's first law. Next time we are going to second law. Newton's first law is stated as following. A ball will remain in its state of rest or motion at constant velocity unless a non-zero net force acts on it. This is a law. It must stay like this. You must state it like this. Me and my colleague, we are stating this law the same. There's no difference. Because this is a law, we are not allowed to change it. You change the law, you get zero. It's that simple. But now, because we're in grade 11, I know they will say, no, we are looking for keywords. There's nothing like that. Nothing like that. Next time we are going to grade 12, you start to struggle. Because in grade 12, they are strict. You need to state the law the same way that is in the exam guideline. Now you must start to claim grade 11 law. You start to go back to grade 11. There's no time for that in grade 12. So you need to know this now, so that next year you cannot start to panic going up and down to your grade 11, to your grade 12. Now you'll be messed up. I don't want that. I'm preparing you now for this law. You must state the law exactly like this. Claim it now in grade 11, so that next year you cannot struggle. A body will remain in its state of rest or motion at constant velocity unless a non-zero net force acts on it. This law is actually saying, if I put this marker here, this marker will stay here forever. Forever. Unless something comes and move it. Unless a net force, unless someone applies a force on this marker and move it, that's when this force will move, this highlighter will move. If nothing moves this highlighter will remain here forever. Another example is saying, if you throw a ball on the straight line, that ball must continue to rotate until it reaches infinity, unless something stops that ball. Obviously, when you kick the ball, when you kick the ball now, the ball will rotate, it will go forward where you kicked it, and then it will start to slow down, but nothing is stopping it. It will start to slow down. Someone will ask, who's stopping the ball? Because the ball is slowing down. There's a frictional force there. There's an external force, which is a frictional force slowing the ball down. If there was no frictional force, that ball was supposed to move forward forever. That's why this law is saying. If you throw something, that thing must move forward forever. It must not stop. But now, because there's a wind force, there's a frictional force, so the ball will slow down and then it will come to a stop. That's what this law is saying. Let's go to our first example. We are calculating now. We are applying Newton's first law, this law. Let me put this guy here close because we are going to need him. Okay, our first question. A body of mass 100 kg rests on a horizontal surface. If the coefficient of kinetic friction between the two surfaces is 0.2, calculate the force. So now, how do I know that this is first law? They are saying here, the body of mass 100 kg rest. You see, that means is not moving. When someone is resting, I'm resting. You know, hey man, can you go to the mall? No man, I'm resting. You are resting. You are not doing anything. Now you can go with that person to the mall because you are resting. You are not doing anything. So even here, a body of mass 100 kg rests on a horizontal surface. It's not moving. So F net is 0. F net is 0. Do you understand? Now I know that I'm dealing with what? With Newton's first law. They didn't say anything about free body diagram, but you cannot calculate without free body diagram. You need to draw the free body diagram. Please, you need to draw the free body diagram. In this case, here's our dot. Make sure your dot is big. Please, make sure your dot is big. I know why. You will see what I'm talking about in Newton's second law. You see my dot is big enough. And then I'm drawing all the forces acting on the object as arrows pointing away from the dots. I'm following the definition of a free body diagram. I'm drawing a free body diagram. They didn't tell me to draw a free body diagram, but you cannot calculate without the free body diagram. You need the free body diagram. So now I have a force that is needed because I'm calculating the force. Calculate the force. This is what is needed. Calculate the force. So I need this guy. Up here I have what? Normal force. And then I have gravitational force. Now, they said to me, if the coefficient of kinetic friction between the two surfaces is 0.2. So now here I must have what? Kinetic friction. So this is 4 marks. You get your 4 marks if it's 4 marks. You get your 4 marks. Free of charge. Free mahala for 4 marks. You are given. So now we need to calculate our frictional force. Let's just write what we are given. We are given the mass of an object, which is where are you? We don't have the mass. 100 kg. What's going on? I can't see now. And then we have the coefficient of kinetic friction as 0.2. So this is what we are given. This is what we have now. So to calculate the force applied, you need to start with this formula. F net, this is our mad, equals to MA. And then what is next? You are showing the marker that I understand that we are dealing with first law. So our acceleration is 0. So 0 times m is 0. So F net is the sum of the forces acting on the objects. Remember, the object is represented as a dot because it's a free body diagram. So now F net is the sum of the forces acting on the object. So now your first step, you need to calculate the you need to calculate the kinetic friction. We are going to take the sum of all the horizontal forces. The sum of all the horizontal forces. So you are going to say F plus Fk. We need to take a direction now. You are going to say we take right as positive. So everything that is going to the left is negative. This is equals to 0. Why did I put positive here? I haven't substituted. When you substitute, that's when you are going to put your negatives and everything. But now I'm creating a formula. I'm creating a formula now. You must put a positive here. You must not put negative. I know that this Fk is going to the left. It must be negative. But it will be negative when you are substituting. I hope it makes sense. So now we don't know the force, we don't know the frictional force. But we can calculate the frictional force with this formula. Okay, here we have this formula that says Fk multiplied by normal force. Do you remember this formula? You'll find it at the back of the question. Oh, grade 11, you don't have question, you don't have formula. This is physics, you have formulas. Thinking about maths, grade 12-ish. So you have formula. This formula will find it at the back of a question paper. Make sure you cram it. And then you know that you are going to write the correct formula. Coefficient of kinetic friction we are given, it's 0.2. This is 0.2. Normal force, we are not given the normal force. We don't know the normal force. But we can calculate the normal force. So you are going to say we are going to take the direction because we are calculating the normal force. Normal force is up and down. I took a direction here as we're taking right as positive. That was horizontal. Now we are taking the direction for vertical. So you're going to take, you're taking up as positive. Everything that is going down, it's negative. Okay? So you have Fn plus Fg, it's equals to 0. Why is equals to 0? Because this object, it's not moving up and down. It's moving left and right. It's moving in the horizontal. It's not moving up and down. So it always will be 0 here. Always be 0. And then you are going to say Fn. We are substituting now. Remember, Fg is going down. It's negative. I said take up is positive. So everything that is going down is negative. So it's Fn minus, remember Fg, you must remember our Fg, this guy, my pen, this guy here, remember this guy, Fg is equals to mass times gravitational force. Do you remember? Fg is equal to mass times gravitational force. So that's what we are going to substitute here. Our mass we are given is 100 kg, and our gravitational force is 9.8. It's equals to 0. So now Fn is equals to minus 100 times 9.8 is 908 equals to 0. Fn, we are transposing, so it will be negative this side. It's positive, so it's going upwards because we took up as positive, remember. So now we have Fn, we have the what? Hey boo, what's going on? Hey, this phone. We have our normal force now. So we are going to substitute our normal force here. Remember, we were still calculating here. Sorry for that, guys. It's our normal force here. So that will be 980. And then we get an answer of 0.2 multiplied by 980, you'll get 196 Newton. So this one is going to the left because it's the kinetic friction. Kinetic friction is going to the left. So here you're going to say left. Forgive me for this. So now we have our Fk. We have Fk now. We are going to substitute Fk where? Here. Going to substitute our Fk there. So Fk, this is sorry, it's minus now because we are substituting, which is 196 is equals to 0. So our F is equals to 196 Newton. Is positive, so it's definitely going to the right. So you see how we are calculating this. Now we need to apply this formula, this concept into our example number 2. You need to apply everything as it is into example number 2. Now someone else will come and say, why are we calculating the normal force? Because normal force is equal to Fg. I know that normal force is equal to Fg. If you have something like this is Fn and this is Fg. If here is 3, even here is 3, I know that. You are correct. If you are saying Fn is equal to Fg, you are correct. But I want you to follow this procedure because now our next example will require this. In this case, you only have two forces. You only have your normal and your gravitation. What if you have an extra force? Now, what if you have an extra force going up? You see, now we have 3 forces. You are not allowed to say Fn is equal to Fg because there's another force acting here. For example, this is just an example. There's another force acting. So you won't be allowed to say Fn is equal to Fg. Let's go to our next example. You will see what I'm talking about. So I hope you understand this, how to find your force applied. Okay, this is our next example. So this I took this from the exam paper. So the question is saying a constant force F pulls a 50 kg block at a constant speed over a rough horizontal surface AB, as shown in the diagram below. The coefficient of kinetic friction between the block and the surface is 0.4. The coefficient that doesn't have the SI unit. Don't try to be fancy and say 0.4 Newton. You'll get 0. Please don't do that. So our first question is saying, draw a free body diagram showing all the forces acting on the block. You see the marks? Let me show you the marks. The mark is 4. The marks here is 4 marks. So now let's draw our free body diagram. Take a new paper, move this one. 2.1. We draw a free body diagram of all the forces that are acting here. That are acting here on this block. Okay. Now let's draw a free body diagram. First, dot, make sure it's big. I know why. You must say your dots must be big. And then now, start by the simple ones. 1. The marks is 4 marks, so the forces must be 4. 2, 3. Now, you see this force here. You see this force is not going straight. It's not going straight. It's going up like that. So you cannot draw a straight line on your free body diagram. It will be wrong. will be wrong. So you must follow this diagram. So our force here will move in this direction, going up. So this is F, and then here we have our normal, we have our FG, and then we have FK again. You are not allowed again to draw the angle. You must not draw this angle. You must not draw this dotted line in this angle. Don't do it on your free body diagram. Your free body diagram is correct like this. After drawing it like this, you leave it. You just leave it like that. So it's 4 marks, you see? It's 4 marks. It's 4. It's 4 marks for your free body diagram. So here are your marks. You have 1, you have 2, you have 3, you have 4. 4 marks, done. You got your free 4 marks. Our next question is saying, state Newton's first law of motion in words. They are telling you that you are dealing with first law. Already in the question, let's read the question again. The constant force F pulls a 50 kg block at a constant speed. There's a constant speed, not moving at all. It's not moving, stationary. So you know that you are dealing with Newton's first law already. So our next question is saying, state Newton's first law of motion in words. They are specific that you must state it in words. Where are my laws? I'm checking my laws. I don't want us to start over and state the law again. So here's our law. Our second question is saying, state Newton's first law of motion in words. A body will remain in its state of rest or motion at constant velocity unless a non-zero net force acts on it. You state it like this, you get your full 2 marks because it's 2 marks. You state it like this, you get your 2 marks. See? It's 2 marks. You get your full 2 marks. Next question is saying, calculate the force F. This guy. You are looking for this guy now. Check the marks. 6. We are going to work now. Now we are going to work. But I'll try to be quick. I didn't want the video to be long. Okay. Now we are calculating. We are in 2.2 is what's definition. So here you need to define. And then you go to 2.3. We're calculating the force. Now we are calculating the force. Grade 11. I'm going to give you a secret. In this case, because you have an angle, you need to go back to your vectors. You remember I told you vectors. You need to go back to your vectors, and you must know how to resolve vectors, because we are going to need that now. We are going to resolve vectors. So in this case, we need to draw our rough free body diagram just here. You cannot do what I'm doing here on the free body diagram that they are going to mark. Don't run things, please. So this is going up. We have our free body diagram here with force F, this force, and then we have 20, and then this is F perpendicular. It's normal because they said normal force is perpendicular to the surface, and then this is F parallel because it's parallel to the surface. It's parallel to the surface. So now, again, applying the same procedure, F net equals to MA. F net equals to 0 because why? MA is 0. So M times 0 is 0. So that's why F net equals to 0. Grade 11. And then now we are coming back here. We are here now. This is a complete free body diagram. But you cannot take this triangle. You cannot have this triangle here. This free body diagram must be like this. And then you draw your smaller free body diagram here on the side so that you can create your equation and then you understand your way forward. You cannot take this information and put it here. Please don't do that. Please don't do that. Don't ruin your marks. Your free body diagram, it must be complete like this. Don't add anything else. And then you draw your smaller free body diagram here to create your equation. So now we have we need to take direction. We are on the horizontal. We are on the horizontal. So this will be, you need to take, we take right is positive. You see this? This is the head to tail. This is the head to tail vector. You remember your vectors. Go back to your vectors and try to memorize them. This is the head to tail vector. So now we are taking right as positive. So you need to look at all you need to look at all the components or the forces that are acting on the horizontal. So we have this one, since right is positive, so we have F parallel plus Fk equals to 0 from here. Remember, from here. So now, F parallel we don't know. Fk we don't know. Hey, this is a problem. Okay. When you resolve the vectors, let us start by resolving the vectors first. Let us resolve the vectors. To resolve the perpendicular, you'll say F perpendicular it's equals to, because it's perpendicular, you remember your SOHCAHTOA, grade 11. So in this triangle here, F perpendicular is opposite. So you need to have opposite over hypotenuse. Which one is opposite over hypotenuse? It's sine. So you'll say F sine 20 degrees. And then you have F parallel, which is F is in the adjacent. So which one is adjacent over hypotenuse? Is cos. So this is F cos 20. So now we are coming back to this. We know F parallel. It's here. We just calculated F parallel as F cos 20. So we're going to substitute F cos 20. Where you see F parallel here, you're going to substitute F cos 20. So we are going to say F cos 20 plus. Now we have a problem because we don't know this guy. We need to calculate this guy. We go back to this formula again. Fk is equals to coefficient multiplied by normal. Fk, coefficient of kinetic friction, we are given. Here we are given coefficient of kinetic friction. When you go back to your question, the coefficient of kinetic friction between the block and the surface is 0.4. So we have 0.4 here. We can say 0.4. And then our normal, we don't have normal. We need to calculate normal. You can't say, in this case now, you can't say normal is equal to gravitation because we have another force. Let me show you this now. We have 1, we have 2, they are no longer 2. In our previous example, there were 2. It was 1, 2. Now they are 3 because we have this guy. You see? We have, and it's going up. You see the arrow there is going up. So we have 1, 2, 3. They are 3. Now you are not allowed to say normal is equal to gravitational force. You are no longer allowed. In our previous video, in our previous example, you were allowed to say normal is equal to Fg because there were only these two forces. Now we have an extra force. You are no longer allowed to say Fn is equal to Fg. I hope you understand. So now we don't have normal. So again, we need to add all the vertical forces, which is 1, 2, 3. So now we need to take a direction again. We take up as positive. So you are going to say Fn plus is going up. You see the arrow is going up. F parallel plus Fg it's equals to 0. I know why I'm saying plus here in the Fg. Fg is going down, I know, but because I'm creating an equation, you must add them first, and then when you substitute, that's when you can put your negative signs and all that. So our Fn, our normal, we don't know, plus our F parallel. Remember, our F parallel is this one. F parallel, where you see F parallel in this equation, you substitute with this F sine 20. So here you have F sine 20. Now minus, we are putting minus now because we are substituting. Remember, Fg is what? Fg is equals to mass multiplied by gravitational constant. So here you are going to have, what is our mass? We are given mass as 50 kg multiplied by 9.8. We are given mass as 50 kg. This is the mass of the block. It's 50 kg multiplied by 9.8, which is equals to 0. I'm trying to put this in the calculator. So Fn, where am I? Okay, minus 50 times 9.8. Minus 50 times 9.8 is minus 490. And then we have plus F sine 20, which is equals to 0. But we are looking for Fn, so we need to transpose these two into the other side. So we have Fn, it's equals to 490 minus F sine 20. I transpose now 490 to the other side is positive, and then Fn is positive this side. When it crosses the equals to sign, it becomes negative sine 20. So now we have Fn. I know we have two unknown. We have Fn unknown, we have F unknown. Don't worry. Now we are going to substitute. Fn is normal force, remember. Fn is normal force. So where you see N is also Fn, N is normal force. Fn is Fn, Fn is normal force. So where you see N here, you're going to say 490 minus F sine 20. And then now, you can leave it here. You can leave it like this. We are going to use this guy. You're going to use this guy. You leave him just like this. So now we have Fk. And then we need to calculate, we need to generate our equation again. I think I did here. You see, where is it now? It's far. I cannot use it there. Okay, let's move this into here. You need to take right. Taking right is positive, so it was F parallel plus Fk, it's equals to 0. Our F parallel is this one. We substitute F cos 20, so it's F cos 20. And then now our Fk is this one. We calculated Fk. Now you put minus because we took right as positive and Fk is going left. So you're going to say 0.4 into 490 minus F sine 20 is equals to 0. And then you are done. You're just going to use your maths, transpose, you add the like terms, and then that's it. So now this will be confusing. I think I can explain it. I just hope I can explain it so that you can understand it. F cos 20, we go up. And then now we are going to open the brackets. It will be u multiplied by this, and then this multiplied by that. See? Opening the brackets. Minus 0.4 multiplied by 490. Calculator. Let's take a calculator. Minus 0.4 multiplied by 490. So you have minus 1996. So you have minus 196. Negative and negative is positive. Okay, here's the tricky part. So here it will be 0.4 multiplied by sine 20. You see, sine 20, we can have a value here. So it will be 0.4 multiplied by sine 20, which will be what? 0.136,136,805 f. Because of this f is not going anywhere. You just said 0.4 multiplied by sine 20. The value that you'll get here, you're gonna multiply it by 0.4 and then multiply by f. This f is not going anywhere, please. This is equals to 0. See, now you have like terms. We have like terms, and then you have this guy, because they both have f. So they are like terms. We need to add them together. So you are going to say cos 20 plus 0.136,80805. You see, because they are like terms. Do you understand? You are going to say cos 20 plus 0.136,80805, because they are like terms. They both have f. So the answer that you will get there is 1.076506 f. So now this will be minus, don't forget this guy, 196. It's equals to 0. We need to transpose 196 into the other side. So we have 0, 196 is positive. We transpose. And then now we divide both sides by 1,076,506. And then we are left with f. It's equals to 182,07 Newton. Because it's positive, definitely going to the right, because you can see f is going to the right but up. But the up doesn't matter, because we resolved that angle. We resolved this angle. If you resolve this angle, that means we are pulling this f here to be in the horizontal, to be here. The f now will be here. When you resolve, you are pulling this guy back into line. He's out of line. It's confusing us. So we are pulling him back into line so that it can be here. So now it's going into the right. You cannot say up. It's not going up. It's no longer going up like this. But now it's going where? It's going into the right, because we resolved it. I hope it makes sense, grade 11. So this was a very long question. But first thing that you must do here, it's not really confusing. The first thing that you must do, you add your horizontal and then you add your vertical. That's it. You start with your horizontal. Your horizontal will lead you to your vertical. You start with your horizontal. You see our horizontal, we did one, so this one, we added this one, and then we added the kinetic friction. F parallel is F cos 20. F cos 20. We don't have FK. Our problem was this guy. We had to find this guy. So now we try to find this guy. Here's the formula to find the kinetic friction. It's coefficient and the normal. We calculated, we were given the coefficient is 0.4, but the normal, we don't have the normal. You cannot say the normal is equal to gravitation. Why? Because now you have a third force. You have force 1, force number 2, and then you have force number 3. You see, now we have 3 forces. It's no longer the same as the previous one, where you have 2 forces, normal and gravity. There you were allowed to say normal is equal to gravity. But here you are not allowed to say normal is equal to gravity, because you have the third force. You need to calculate it like this to find Fn, to find the normal force. So when calculated normal force, as I said, that your horizontal will lead you to your vertical. So when you get to your vertical, you take the direction first. You take up as positive. You put all the vertical forces. There are 3, as I showed you. 1, 2, 3. You add them. You don't take you don't include the direction yet, but you're going to add all the forces. This is what the procedure is saying. You add all the forces first. It's Fn normal force, F perpendicular, and the gravitational force. They are all equals to 0. Why equals to 0? Because this object is not moving up and down. It's moving left and right. So these forces, they are actually they are not there in this object. So now you need they are all equals to 0. And then F parallel, we have F parallel, it's here. You're going, where you see F parallel here, you're going to substitute F sine 20. So we substituted F sine 20 minus Fg. Remember, Fg is Fg equals to mass times gravitational constant. Our mass we are given, it's 50. Our 9.8 is constant. You'll find it at the back of equation paper, don't stress. And then you add the like terms, and then there you go. Our Fn is this one. I know it's not the usual one, the one that you are used to. I know that you are used to a whole number or a normal number, but in this case we have 490 minus F sine 20. This is the answer that we got. It's fine. We take this number that we got because it's n. This is also n. It's n. This n is this n. We take that n, you substitute it here. Where you see n here, you substitute with this value that you calculated. You see, our Fk you are given, and then when we see n, we substitute. We found our Fk. We're coming back here into our horizontal forces. We have this guy, is this guy, F parallel. We have F parallel. We calculated F parallel. It's F cos 20. Where you see F parallel, you substitute with F cos 20. Minus now, because we are substituting. Remember, now it's time to substitute. When we write the equation, we didn't put minus. I know that Fk is going to the left, and I said take right as positive. So everything that is going to the left is negative. In this case, I said positive because we are still generating an equation. We are still generating our own equation. So now, when you are substituting, everything changes. Now we follow the direction here because our Fk is going where? To the left. So it must be negative. So here's the negative. And then you just put your Fk exactly as it is. Take it here, you put it here. And then you open your brackets here, and then you add like terms, you transpose, you divide, and then you get your answer. This is your force. I hope it makes sense, grade 11. If it doesn't make sense, you can ask questions, and I'm happy to answer you. Next time we meet, we are going to Newton's second law, which is where the party is. There is the party. There's a party there. So you need to prepare your Newton's second law so that when I come here and present your Newton's second law, you'll know, at least you'll have a clue. And then I will try to dissect it, and then I'm just hoping you'll understand. Okay, grade 11, thank you very much. Our lesson for Newton's first law ends here. Have a good night.